Hello everyone, and today we're going to discuss a published agricultural study that uses carbohydrates and proteins. And a published study that we choose to discuss is all about proteins from agri-food industrial bio-waste or co-products and their applications as green materials.
Abstract. A great amount of biowaste, comprising byproducts and biomass waste, is originated yearly from the agri-food industry. These biowaste are commonly rich in proteins and polysaccharides and are mainly discarded or used for animal feeding. As regulation aimed to shift from a fossil-based to a bio-based circular economy model, biowaste are also being employed for producing biowaste materials. This may involve their use in high-value application and therefore remarkable revalorization of these resources. The present review summarized the main sources of protein from biowaste and co-products of the agri-food industry: wheat, gluten, potato, zine, soy, rape, sunflower protein, casein, whey, blood, gelatin, collagen, keratin, and algae protein concentrates. Assessing the bioplastic application. Food packaging and coating controlled release of active agents, absorbent and superabsorbent materials, agriculture, and scaffolds, for which they have been more extensively described, as well as the main characterization techniques. In this sense, the strategy of reducing materials from biowaste to be used in agricultural application prospect, including environmental and economic and social angles. This approach allows envisioning a reduction of some of the impacts along the product life cycle, contributing tackling the transition towards circular economy.
Introduction. The accumulation of plastic waste is a globally recognized problem that involves an extremely negative impact on the environment. The exceptionally low biodegradability of fossil-based plastic, together with the massive production scale associated with the plastic market over the past 60 years, has generated a huge accumulation of plastics and landfills and the ocean. To illustrate the magnitude of the problem, considering that almost 400 metric tons of plastic waste is generated every year, there is currently more than 1 ton of plastic person alive in the world. However, in spite of the recent efforts made in the field to shift from the fossil-based to a bio-based circular economy model, only 20% of plastic is collected for recycling, of which only 3% is reused. The rest is incinerated, landfilled, or disposed of into nature, a large part of which is ending up in the oceans. In the sense, European United Directive or EU 2019 prevent to reduce the impact of certain single-use plastic products on the environment, especially to the marine environment and human health. Consequent, the future of the plastic industry needs to be driven by sustainability issues, where the bioplastic sectors is a crucial building blocks for a circular economy scenarios.
The vast majority of traditional institutions during the Middle Age in Europe, such as the classical Greek Roman, and Arabic regions had their own herbal gardens for healing patients and teaching purposes about herbal plants. About 75% of people worldwide still rely on plant-based traditional medicines for primary health care.
Application of protein-based bioplastics. The main agri-food, industrial biowaste, and co-products for bioplastic application has been described in the previous section. Food biowaste can be used for the production of biofuels, but the present review focuses on their application in the field of greener materials, which has been extensively studied but it's less exploited commercially, especially the protein fraction. The selection of suitable biopolymer source is key in the development of any final product with a particular application, which may be chosen based not only on its processing suitability but also on consumer requirements. For instance, animal proteins are commonly rejected in cosmetics despite being widely accepted in agricultural application. Moreover, the design and development of bioplastic materials need to bear in mind the accordance between service condition and final mechanical and function properties of the material developed. Although many researchers focus on the mechanical properties of bio-based bioplastic, many applications like super absorbent, drug delivery, controlled release, or etc. do not require excellent mechanical properties for their final usage. Some critical requirements are demanded for these bio-based materials when used in food application. For instance, food quality and safety during storage should not be compromised. Moreover, extended shelf life and reduced permeability to volatile compounds, oxygen and moisture, are also pursued. This section summarizes the main application for the agri-food industry, biowaste whose end use can be linked to the goals of the bioplastic industry. Moreover, this section also addresses the requirements of these bio-based materials for certain application.
Finding gathered in the present review put into focus the wide versatility of bioplastic manufactured from agri-food, industrial biowaste or co-product, although in limit for their applicability are still far from being fully explored by the scientific community. In the relatively near future, conventional plastic will disappear in a single-use application following the European strategy for plastic in the circular economy, which aims to transform the way plastic products are designed, used, produced, or recycled in the European Union. Most current applications are focused on the use of lignocellulose starch of fats from food biowaste, and the protein function is mostly relegated to low-value application. However, as highlighted in the several applications described above, there is a solid synthetic ground to industrial exploit those protein-rich biowaste, and co-products techniques like electrospinning or 3D printing have yet to further develop their potential to do so, and protein which are non-competitive with the agri-food industry, such as replace or keratin, may find a privileged position. However, the excess of co-products that are the only minimally used the agri-food industry despite being edible, such as blood from the meat industry, should be better employed in application like those herein presented in agreement with circular economy. When bioplastic generated from biowaste and co-products such as those herein indicated are competitive, the law of supply and demand will help to mitigate their use.